The sun. Although it's a part of our everyday life, this awesome object around which our galaxy rotates provides energy for all life on Earth. Penetrating the Earth's atmosphere, the sun's rays make their way to the Earth's surface, immersing it in its warm radiation. To the sun, all life owes its growth and very existence. But how can we harness the solar energy that a plant so easily does? Through the photovoltaic process. The photovoltaic process was discovered quite some time ago. In 1839, Edmund Becquerel discovered this process while he studied physics under his father. Focusing on the study of light, he was investigating the photochemical effects and spectroscopic characters of solar radiation. This led to his discovery of the process. In 1904, Albert Einstein published his famous paper describing the physics of the photovoltaic effect. He later went on to win the Nobel Prize for his work in photovoltaics. In 1954, Bell Labs unveiled the world's first photovoltaic module. Photovoltaic is known as PV. In a PV system, the PV modules are an essential component. A PV module is the instrument that is used to absorb the sun's energy and convert it to electricity. In the 60s, PV modules were used in the space program to power satellites and landers for research in space. They had no problem operating thanks to the sun's abundance of energy. So you'll agree, PV is nothing new. Now let's talk about what makes a PV module work. A PV module is comprised of numerous PV cells. These PV cells consist of two major components. There is N-type silicon and P-type silicon. N-type silicon has an abundance of electrons. P-type silicon lacks electrons. When the sun's rays hit the N-type silicon, the photons knock off the extra electrons. Those extra electrons are then attracted to the P-type silicon. What engineers have done is to place current-carrying conductors such as copper wire in the paths of these flowing electrons, creating a current that can be utilized and provide you with power. N-type silicon and P-type silicon are made by a process known as doping. In order to utilize the power from the PV, the DC current from the modules needs to be converted into AC current. The type of electricity we use to power our refrigerators, TVs, and lights. What's known as an inverter is installed. You'll be glad to know that most modern inverters come with surge protection and charge controller technology inside the inverter itself, making the inverter more robust, as well as increasing the efficiency of the entire PV system. The PV circuit is then wired to the home's circuit breaker panel board, providing you with additional overload protection. In most cases, in Wisconsin, the power is then routed to the utility's electric meter that is installed on your home. When there's demand for power in the home, the modules provide that power if the sun is out. Should there be no demand in the home, when the sun is shining, any excess power produced by the PV will be placed back on the grid. This setup is called net metering and is standard for all utilities operating in Wisconsin under the authority of the Public Service Commission. When energy is produced, we need to store it if we can't use it right away. So think of the grid as a giant battery. Because of the large size of the grid and the large amounts of power being demanded on it, when we put power on the grid, rest assured that it's going to find a use somewhere. It turns out that when the sun is shining, it's also the same time when there is the largest demand for power on the grid. Therefore, by installing PV on our homes, we can mitigate some of that peak demand on the grid. If you produce energy and place it onto the grid, you get credited through net metering. Some systems are big enough to generate revenue for you. Solar PV is the only home improvement that can pay your bills for you. PV systems add value to your home as well, and in Wisconsin, municipalities cannot tax you on increased property value from renewable energies. It's the law. In addition to state financial incentives, there's also a 30% tax credit available from the federal government for installing solar on your home. While generating revenue for you and your home, a solar PV system will reduce your carbon footprint to boot. To preserve our natural resources, we must all make a contribution. PV is a great way to do this. Not only can it help you reduce your carbon footprint, it can also benefit your home, and your family as well. It's no shock then that solar PV can take you there, and Badger Solar will be there every step of the way.